Do you have a number as a result?
I have 0.2.
Yeah, that's right. Okay, that's great. 1.1. That's not the right answer. Maybe you meant 1.2. Let me see. Never mind. Okay, I'm gonna explain that. So first, let's grab my pen again and see. We have to calculate the conditional probability that more than 5 shirts were sold. Let's say that's Y. More than 5. Conditional, the information that we already have, that more than 3 t-shirts were sold. So Y, more than 3. Is that clear? That formula is just the intersection between those two, which is Y being more than 5 and being more than 3. It means that the first part says it has to be more than 5, which means has to be just 6. If it has to be more than 3, it has to be from here on the right. So that part and that part. And we see that the intersection is where the 6 lies. So it has the probability of Y being equal to 6 over the probability of Y being more than 3. And Y being more than 3 is all those 3 summed up, which is 0.2 plus 0.2 plus 0.1, which is 0.5. And by the table, we are given 1.1 as probability of 6, which becomes 1.1 over 1.5. Was that easy, hard, or how did you find it?
Yeah, I think it was pretty easy, but I don't know.
It depends.
Yeah.
Do you have a question, Miriam, or you just want? Okay, because I see you're moving and I wasn't sure if you're taking notes or so. So one more based on the same table. Okay, that's the answer, but I already wrote it. Oops. And one more, and it asks us for independence. We have to decide if the events X being more than 3 and X being less than 6 are independent. Do you remember the formula that was for independence?
No, can you share that one again?
Yeah, sure, of course. Not sure if others need a second just to think about it, or should I? Okay, I will just write it. The probability of those events X being more than 3, given X being less than 6, if it's equal to the probabilities of their separate parts, that means they're independent. So just to write it, times the probability of X less than 6. If that condition is okay, it means we can just put the equal sign. It means they're independent. And we just have to double check with the table those probabilities. Firstly, we need to have a look at here. x being more than 3, given x is less than 6, it would equal the intersection between those two, the intersection, which is being less than 3, sorry, being more than 3, which is that part here, 4, 5, and 6, and less than 6, which would be everything, but it doesn't switch here. That's the intersection here. So it is 0.2 plus 0.2 divided by the probability of x less than 6, which is just everything but not 6. And the easiest way to calculate it is just 1 minus 0.1, which is 0.9. And we have to check again those probabilities here. We have x being more than 3, which is that part here, which is 1.2, 0.2 plus 0.2 plus 0.1, which is just 0.5. And being less than 6, being less than 6 is everything but not 6, which is 1 minus 0.1, which is 0.9. And that's the only, and maybe just you can calculate those numbers and let me know if that number here equals that number here.
What do you have to do with the numbers on the right? Do you have to multiply them?
Yeah, multiply, yeah, sorry.
No.
Yes, that's correct. So that means it depends if those numbers here are with decimals around it or it's not. But we have to be really precise. They're not equal because we have 0.44 and 0.45. So that means they're dependent. If that condition, if the same number was on the left and on the right side, that means those events are independent. But that's not the case in our exercise. And we have two dependent events. Do you maybe want another example with dependence, or it feels right?
I understand that I don't necessarily need another one.
Great.
Same for me.
Great. We have one vote for another example. What should we do? I don't know. Okay, I'm gonna give one example. Let me. Are you still taking notes, or I can delete it?
You can continue.
Okay. For fatigue, I would say calculate the probability of those two events, and in the break, I'm here, so you can always type in your answer and I can check it up with you. The probability, let's say x is more than 5 and x is less than 4. Are those dependent or independent? If you want, in the break, you can calculate it and let me know if you want. So let's not. That we already did. Are you tired, guys? Or you can continue?
I think I understand it. You can continue, but show me the last slide.
Sorry, I couldn't hear the last part.
The other slide. The other slide.
Ah, the other slide. Okay. How the others like it? Do they want to continue? Or?
For me, it's fine. You can continue.
Okay. So let's have a look at the exam again. Great, we can continue. I feel like sometimes it's a bit too tiring, but maybe for me when I'm talking over and over again, and I feel, yeah, but I'm happy that you're not tired. We have again events, and of course a random experiment. And we are given the probability of A, C, and D, and B condition A. And we also know that C and D are independent. We can use the formula from the previous slide. And we have to determine the intersection between A and B. Let's go step by step. Maybe I can give you the formula if you're not.
So the first answer is 0.1.
Yep, that's true. We just plug in the numbers in the formula, that's it.
Yeah.
And the second part of the first question, do you have an idea? Do you have an answer for A intersection B complement?
Would that be 0.15?
Yes. And how do you calculate this one?
Because the probability of A is equal to the probability of the intersection between A and B, and plus the probability of the intersection between A and B complement.
That's right. That's right. So we just we can also the probability of A minus what we already found here, the probability of A intersection B. Because we have here complement, which means everything but not the complement, which is in A. Oops, that was so... .15. So let's go to the second one. We have to find the union between C and D. And if we just remind ourselves of the picture. The formula for here should be the probability of C plus the probability of D minus the common part, that is the intersection, right? There's nothing weird here. Intersection D. We know from the exercise the probability of C and the probability of D, but we are missing that part here. What can we do? We are also said that C and D are independent. And if they're independent, that means that this thing here should equal probability of C times the probability of D. That is the same as the previous exercise. But we already know C and D, so it should be easier to calculate the intersection between C and D. And we already have all unknowns, so it would become probability of C, which is 0.4 plus 0.3 minus 0.4 times 0.3. We just have to use that C and D are independent. If
So
you
the
wanna see-
answer is 0.58.
0.58.
Yeah.
Yes, that's the answer. The final one. I'm not sure if those drawings are understandable to you, so better see it typed in the presentation. If we have some information in the exercise that is given, but we don't know how to use it, just see what questions ask us for information that we don't have. If it asks us for something that we should all have all the information that we need, but sometimes we cannot relate some of the information to particular question. So that's the way to approach it. And the last question, it asks us for subsets. If A is a subset of B. If A is indeed a subset of B, so let's imagine that's B, and A is a subset, it should be inside. That means the intersection between A and B, which is that part here, should equal to A, because that is a subset that's inside B. And we can check that. We have the probability of A, which is 25.25, and the probability of intersection, we already found 0.1, but that's not equal to each other. So it means that A is not part of B, it's not inside in B. Was that clear, or? I just remembered, if you want to practice for the continuous and discrete variables, when I was making the presentation, I found a really useful website, but I have to find it here. Discrete and conditional. I'll just say it in the chat if you want to just have a look at more examples. So let's go back. So we are here, right? Yeah. Break slide, but let me know how do you feel and if you need it. There's another chapter coming about expectation, formulas, variance, and standard deviations.
Yeah, maybe take a small break and then.
Okay, yes, okay, because that would be a bit harder than what we already did. So yeah, fresh in our minds. Okay, do you wanna? So let's have 5 minutes break, and we're gonna continue. Tricky maybe. One. Your exact number. Or so. I would say I'm only first year.